Hello, and welcome to the Trepid Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.1 Secure Protocols. Now let's get started. As part of the Security Plus exam, you must understand and implement security protocols on your network. We use different protocols and ports for all sorts of functions on the network. And when these were built, security was not in mind. This was the late 80s, 90s, and early 2000s when a lot of these protocols like FTP, Telnet, RDP were created, and they were not thinking about security. So to combat these inherently insecure protocols, we have added secure extensions or new protocols to use in the enterprise. The first one we're going to talk about is DNSSEC. DNSSEC stands for Domain Name Security Extension. This DNS extension ensures authentication, integrity, and non-repudiation in our DNS requests. DNSSEC uses digital signatures and the public key infrastructure, or PKI for short, to ensure our users use a trusted DNS authoritative server for named IP resolution. This is going to help prevent DNS poisoning attacks by making sure you always send DNS requests to an authenticated and authorized server, not a rogue server, right? We don't want that. As IT administrators or security administrators, we must always log into our systems, or not always, but if remotely, right? We'll have to use a remote desktop or remote terminal connection to configure and manage our systems via CLI. SSH is the secure solution for remote sessions to our systems. SSH can be used to protect our in-transit information using RSA keys when we connect to our remote systems. SSH is the replacement for the unsecured remote session protocol Telnet. SSH will use port 22, and again, it's going to encrypt our data in transit. And as you can see here, we have a PuTTY terminal emulator here, and we're going to use the SSH protocol to remote in to this system's IP address. SMIME is a standard for encrypting MIME data, which stands for Multipurpose Internet Mail Extensions, which builds off the original Simple Mail Transport Protocol, SMTP. We use these protocols for sending data, text, and files over email. The S stands for secure, and SMIME is the secure implementation of the MIME protocol. The real-time transport protocol sends UDP data and voice and video. The S also stands for secure, and SRTP is just an extension of RTP that provides confidentiality, message authentication, and replay protection. So again, this is just the secure implementation of an already well-known and established protocol, RTP. Another thing I forgot to note is that when using webmail or OWA, SMIME is sometimes hard to use or has trouble being implemented because of the public key infrastructure. Not impossible, but just something to be aware of in your enterprise. LDAP stands for Lightweight Directory Access Protocol, and it is the backend protocol that is used for providing domain services like Active Directory. LDAP is another inherently insecure protocol, but we can add security to it by adding SSL or TLS encryption to LDAP traffic, thus securing our LDAP data in transit information. We call this secure implementation LDAPs, right? So Lightweight Directory Access Protocol over SSL, and it's going to use TCP port 636. So if you do an Nmap scan of your network and you see 636, know you're using LDAP over SSL, which nowadays will be TLS, right? Because that's a secure implementation, SSL being insecure. The file transfer protocol is a standard for transferring files over an IP network. And just like every protocol created way back when technology was just starting, right, or IP technology, it's also inherently insecure. FTPS, File Transfer Protocol Secure, It's also going to add SSL or TLS to FTP. And that's going to use port 990 for control and 989 for data. Because we know FTP has ports used for control data and actual data, right? Excuse me, for control and one for data. And then we have SFTP. This is an extension of the SSH protocol. This will allow file access, transfer, and management. And there's a big difference between SFTP and FTPS because SFTP is not an extension of the original file transfer protocol. It is an extension of SSH that allows file transfers. So we're not using TLS or SSL to secure our data in transit. We're using SSH in the SFTP protocol. And since it uses SSH, we're going to use port 22. And then we have the Simple Network Management Protocol, or SNMP. Excuse me. SNMP is a protocol that allows the management of network devices like switches, routers, firewalls. And SNMP, when it's created, was also inherently vulnerable and an insecure protocol. So now we have SNMP version 3, which is going to add authorization and encryption to the SNMP protocol. So this lets us use hashing, right, and encryption on our SNMP messages. And then we have the Hypertext Transfer Protocol, which we should all be familiar with, right? Because if you're on YouTube or my website watching this, you're using it. HTTP is the Hypertext Transfer Protocol that everyone uses if they want to browse the internet. The Hypertext Transfer Protocol, again, is used when you're going to a web server. So HTTP traffic is sent in the clear and plain text. So we created HTTPS, which is the secure flavor of HTTP, which again uses SSL and TLS for its connections. And this is going to be over port 443, HTTPS, whereas HTTP uses port 80. And then we have a whole slew of email protocols that are inherently vulnerable, like POP3, IMAP, or SMTP. And a lot of them will support the use of SSL or TLS encryption over them, right? And you see their port numbers used. So we didn't make a slide for each individual one because a lot of this is the same, right? If you're using IMAP, POP3, or SMTP, you can use SSL, TLS over that protocol to give it data in transit protection. The last thing we're going to talk about is IPsec, or the Internet Protocol Security. This is a suite of protocols that protect data in transit. IPsec is going to provide data authentication, integrity, and confidentiality. IPsec is typically used as a VPN solution for roaming clients who want to gain access to the corporate enterprise. So what do we mean by that? Typically we're going to see IPsec used, and let's say we have our headquarters here in, let's say, Phoenix. And then we have a remote office, let's say in like Albuquerque, New Mexico. And then we have users at their home, right? Here's a little house that also need to get access to that HQ network because maybe this is where our data center sits for all of our enterprise services. So on this router, or maybe we install a VPN concentrator, that's going to be the hub for IPsec connections. And so this router is going to create an IPsec tunnel here, a site-to-site VPN, right? Site to site. And then maybe this user uses something like Cisco AnyConnect that's also going to use IPsec in the background to connect to this network, right? And that's typically how we see IPsec implemented. So IPsec is also the protection overlay in our GRE tunnels, which are configured on networking devices. And pure IPsec traffic will only send unicast traffic as well. And we're not going to dive too deep on this because, again, this is a Security Plus exam, not a CCNP security exam. So IPsec can operate in two different modes, tunnel and transport. In the tunnel mode, we'll encrypt the data, payload, and the IP header. In transport mode, it will only encrypt the IP header, right? and the data payload will be left unencrypted. So typically we always want to use our tunneling mode, right? All right, so that's it for this video. I want to thank you for viewing, and stay tuned for our next video where we will discuss Domain 3.2, host and application security. Thank you.